My name is Madhav Kaushik and I'm going to explain the Apriori algorithm with the help of an easy example. So a set of items is called an item set. If an item set has k items, it is called a k item set. An item set that occurs frequently is called a frequent item set, and it is called frequent if it satisfies the minimum threshold value for support and confidence. Before we look at the definition of support and confidence, let's look at the property on which the Apriori algorithm is based. It is based on anti-monotone property, which states that if an item set is infrequent, then all of its supersets will be infrequent as well. So in the given figure, if it is found that AB is infrequent, then all of its supersets ABC, ABCD, ABCDE will be pruned because they contain a subset which is infrequent, and hence they are infrequent as well. Support count is basically the frequency of the item in the dataset. Support of an item is the number of transactions in which that item appears divided by the total number of transactions. And confidence is basically how likely an item Y is purchased when item X is already purchased or it is already in the transaction. It is computed by the support of both the antecedent and the consequent divided by the support of the antecedent. Steps of the a priori algorithm. There are basically two steps. There is a joining step and there is a pruning step. In joining step, we are basically generating k plus 1 item sets from k item sets by joining each item with itself. And if there is an item that does not meet the minimum support, it will be infrequent and it will be removed. The basic idea is to reduce the size of the candidate item sets that will be generated. Now that we have an overview of the algorithm, let's look at an example. Here we hope to find strong rules from the transaction set given below. We are considering the minimum support or min sub to be 50%, that is 0.5, and the minimum confidence or the min conf to be 60%, that is 0.6. That right here is our data set on which we'll work. So first we will generate frequent one item sets. So we will generate the frequent item sets. Now how will they be generated? We will compute the support for all of the items in the transactions. So let's say for I1 the support will be the transaction in which I1 occurs divided by the total number of transactions. So I1 occurs in 1, 2, 3, 4 divided by the total number of transactions that are 6. So the support will be 4 by 6 or 0.67. Similarly, we can compute the support of I2, I3, I4 and I5. We can see that the support of I5 is 2 by 6 or 0.33, whereas the minimum support was 0.5. So this item lies below the minimum support and hence it will be pruned. It will not be included in the frequented item set, which will only include item I1, I2, I3 and I4. Now we will generate the frequent 2 item set, which will be generated with the help of frequent 1 item set. We basically take groups of 2 and we do it as follows. We will consider I1 with I2, I1 with I3, I1 with I4, I2 with I3, I2 with I4, I3 with I4. We are covering all the possible combinations. And then we will compute the support for them. So these are the items and we will compute the support for them. So let's consider I1 and I2. In how many transactions does I1 and I2 occur divided by the total number of transactions? So I1, I2 occurs here, 1, 2, 3 and 4. So 4 divided by the total number of transactions, that is 6. So 4 by 6 is 0.67. And similarly, we can compute the support for all of the item sets in this table. We can see that there are two cases in which the minimum support was not satisfied. That was I3 and I4 and I1 and I4, which both have a support value of 0.33, whereas the minimum support required was 0.5. So these two will be pruned and they will not be considered further. So the frequent 2 item sets will be these 4, and we can see that that all of the items are basically still here. Item I1, I2, I3 and I4 except I5 that was pruned earlier. So now we will generate the frequent 3 item set with the help of frequent 2 item sets. We will consider the groups of 3. So I1, I2, I3, I1, I2, I4, I2, I3, I4 and I2, I4 and I1, if that was not covered earlier. Uh, So I1, I2, I3, I1, I2, I4, I1, I3, I4, I2, I3, I4, and we will compute the support for these 4 values now. Uh, so let's take item I1, I2 and I3. Let's see in how many transactions does I1 item I1, I2 and I3 occur. So 1, 2, 3. It occurs in 3 transactions and the total number of transactions are 6. So 3 by 6 will be 0.5. And similarly, we can compute the support for these 3 items as well. We can see that there is only one case in which the minimum support value is satisfied, that is item I1, I2 and I3. which has a support count of 3, which is equivalent to the minimum support count that was required. Let's look at this in another way. Let's talk about the subsets of item I1, I2 and I3. They are I1, I2, I1, I3 and I2, I3. All of these subsets are frequent, as we can see from the previous table. And basically all the subsets of this superset are frequent, and so this superset would have been frequent. This satisfies the anti-monotone property. Now we will generate the rules, because no frequent 4 item set can be generated as there are only 3 items left. So we will generate the rules. Basically we'll write them as follows. We can see that we have I1, I2 and I3 here, so we can say that I1 and I2 gives I3, I1 and I3 gives I2, I2 and I3 gives I1, and we can switch it up. So I3 gives I1 and I2, I2 gives I1 and I3, and I1 gives I2 and I3, which basically means that we are taking that I1 and I2 is associated with I3. We will now compute the confidence. So we have I1, I2 gives I3. We already said that we will compute it by using the support of both antecedent and the consequent with the support of the antecedent. So in all the cases and all the rules that are generated, the support of both antecedent and consequent together, the support of I1, I2 and I3 will be same, that will be 3. So the numerator in all the cases will be 3. Now let's look at the denominator, in which we will consider the support of the antecedent. Let's say the support of I1 and I2. We know that the support of I1 and I2 is 4. Actually the support count is 4, but if we are considering support count in both the cases, or if we are even considering support, then the total number of transactions that is in the denominator will be cancelled out, so we will be simply left with support count. So it will be 3 by 4, which means that the confidence will be 0.75. Similarly, in the case of I1, I3 gives I2, we have I1, I3, I2 support as 3 and I1, I3 support as 3. So 3 by 3 will be equal to 1. And similarly, we can compute the confidence of all of these rules. We can see that the confidence of all the rules generated is greater than or equal to the minimum confidence value. That was 0.6. Therefore, all the rules that are generated are strong. So they all will be included in the rule set. Limitations of a priori algorithm. If we take the minimum support value as too low, then there will be a large number of candidate item sets generated. Also, we will have to scan the database many times for finding the candidate item sets. When there are large number of transactions and the memory capacity is limited, a priori algorithm will be slow and inefficient. Certainly, there are better ways to find the association rules than a priori algorithm, such as FP growth. But we'll conclude our session right here. Hope you learned something.